Hello everyone, this is Linu. Welcome to Learnwizz. Hope you guys are doing well. Yes, in today's video we will be discussing about how to calculate the empirical and molecular formula of compounds. Okay, and this topic is from some basic concepts of chemistry, chapter 1, grade 11. Okay, so make sure you stay till the end of the video. Okay, and don't forget to hit that subscribe button and ring the bell icon so you will never miss an update from us. So let us move on to the topic. See, you are going to discuss empirical and molecular formula calculations. So first of all, you must know what is empirical formula and what is molecular formula, right? So simply, I will explain with an example what is empirical and molecular formula. And you guys know the molecular formula of glucose, right? Glucose. What is the molecular formula of glucose? It is C₆H₂O₆, right? And you guys also know the benzene. What is the formula of benzene? Molecular formula it is C₆H₁₂, right? Yes. Now see guys, when you hear the molecular formula of glucose or benzene, what all things you will get from here? You will get the elements present in glucose, right? What are the elements? Yeah, carbon is there, hydrogen is there, oxygen is present, right? And what about benzene? Yes, you will understand that benzene contains carbon and hydrogen. And what another information you will get here? You will also get how many carbon atoms and how many hydrogen atoms and how many oxygen atoms present in glucose, right? That is, the formula gives the complete idea about the number of carbon atom, that is 6, number of hydrogen atoms 12, and number of oxygen atoms 6. Like that, in benzene, you will get the information about there are 6 carbon atoms and 6 hydrogen atoms in the molecular formula of benzene. Okay, so this is the molecular formula of both benzene and glucose. Okay, now see, I'm going to write its empirical formula. Okay, now you guys have to tell me what is the difference. Okay, what is the difference between molecular formula and empirical formula? Okay, so empirical formula of glucose is CH₂O and that of benzene is CH. So by analyzing the empirical formula of glucose and benzene from its molecular formula, it is crystal clear that it is the simplified version, right? C₆H₂, we have divided it completely with 6, right? You will be getting the empirical formula. That means what? It is the simplified ratio or the simplest form of the number of atoms present in the one formula unit of that compound, right? That is empirical formula. So what do you understand? Molecular formula will give the complete information about the different types of elements as well as the number of atoms of each element. But empirical formula gives the idea about what? The simplest ratio of the elements present in the compound. It will not give the idea about the how many atoms are present in the compound. Okay, so that is the difference. Okay, now let us move on to how to calculate the empirical formula and molecular formulas. Okay, let us see here. There are certain rules for determining empirical formula. Just I will explain the rules. You will understand the concept by doing only the questions. Okay, see, you will be given some percentage composition of the elements in the compound, like hydrogen this much percentage, oxygen this much percentage. Okay, and what you have to do? You have to convert the percentage composition into mass. Imagine you are given 10% of hydrogen. So what you have to do? You have to assume that this is 10 grams of hydrogen. Okay, totally you are taking the complete mass of the sample as 100 gram. Out of that, 10% of hydrogen means 10 gram of hydrogen. Okay, and you will be given another percentage, 50% oxygen, like that. So what you have to do? You have to write down like 50 grams of oxygen. Okay, after converting the percentage composition data into mass data, what is next? Next, you must know the molecular mass, the atomic mass of the elements given in the question. Okay. After that, you have to convert into number of moles. So, what is the formula of number of moles? Number of moles, how will you calculate number of moles? That is equal to given mass, or what mass is given in the question, over the molar mass of that particular element. Okay. If you get hydrogen as 10 grams here, how will you calculate the number of moles of hydrogen? Number of moles of hydrogen is equal to 10. That is a given mass over what is the mass of hydrogen? Molar mass is 1. So you'll be getting 10 moles. Okay. So that is the second step. You have to determine the number of moles of each element in the sample by dividing the mass by its molar mass. Okay. And what is the third step? Then you have calculated all the number of moles of the given elements. Okay. If it is hydrogen, oxygen, nitrogen, everything you calculated. After that, you have to select the lowest number of moles. Lowest number. Which one is having lowest number of moles? Okay. And after that, you have to divide completely with that lowest number to all the number of moles. You will be getting somewhat whole numbers. Okay. So that is, convert the number of moles of each element into whole numbers. That becomes subscript in the empirical formula. So that number will become the subscript in the empirical formula by dividing each amount in moles by the smallest amount. Okay, you have to take the smallest amount from the moles. You have to divide completely all the number of moles with the smallest amount. You will be getting some whole numbers. Okay. Yet, if you miss to find the mole numbers, then what do you have to do? You have to take the common multiple of that. Okay, you have to convert the decimals into what? Whole numbers. That is the fourth step. Okay, hope you guys understand the steps. Okay, convert the percentage composition data given into the mass. Okay, and next step is calculation number of moles. After finding the number of moles, what you have to do? You have to select the lowest number of mole. Okay, and you have to divide it completely with the all. You will be getting the whole numbers. Again, if you are not getting the whole numbers, what you have to do? You have to multiply. You have to use. Okay, multiply all subscript by the least common multiple. That is, okay, when you do the questions, you will be getting the complete information. Don't worry. Okay, let us move on to the questions. We will discuss some questions now. Okay. Yes. Question 1. Determine the empirical formula of a compound containing 69.88 gram of iron and 30.12 gram of oxygen. In this question, instead of percentage composition directly, the mass is given. Okay. So, no need of converting the percentage into mass, right? So, we can directly move on to the second step. That is, we have move on to the second step. That is, we are converting the mass. So, this is the mass of iron given mass. You have to divide it with the molar mass of iron, that is 55.85, approximately 56. Okay. And after that, 30.12 is the given mass of oxygen. You have to convert it into what? Number of moles of oxygen. So first step is completed. You get the moles of oxygen and iron. What is the next step? Which one is the lowest number? This or this? Of course, iron's moles, right? 1.2512 mole of iron. So you'll be getting what? You have to take that lowest number of moles and you have to divide completely throughout. That means iron, and also for oxygen you have to divide it. Okay, so you'll be getting what? Some ratio of the elements present here. So iron is 1, dividing 1.2512 over 1.2512, you'll be getting 1. And by dividing this moles of oxygen with the least smallest amount of mole, you will be getting a value 1.5. Now see, this formula, is it complete? No, right? Because again, this is not what, this also decimals coming, right? Not a whole number, right? So you have to convert it to whole number. So 1.5, I will convert this 1.5 into whole numbers. You have to multiply with 2, right? So you'll be getting as 1.5 as 3. So that too you have to multiply with iron also. You'll be getting what? Empirical formula as Fe2O3. Okay. That is the empirical formula calculation. So divide all the moles amount by the lowest mole amount. That is our second step. And determine the least common multiple that will make all the subscript whole numbers. So this is the subscript we get in the beginning. But this is not whole number. So you have to multiply with the least common multiple so that you get completely the whole numbers. So we'll be getting Fe2O3 as the empirical formula. Okay, fine. Yes. Next, another question. Let us move on to another question. Determine the empirical formula of a compound containing sodium, hydrogen, carbon, and oxygen. A big compound, right? Now to calculate its empirical formula. Now let us move on to this given as percentage, right? Okay. So first of all, you just convert the percentage into what? It's gram. That in grams. So we'll be getting 27.37 gram sodium, 1.200 gram hydrogen, 14.30 gram carbon, and 57.15 gram oxygen. Okay, what is the next step? You have to find out its what? Molar mass. Molar mass already written. Sodium is approximately 23 and hydrogen 1, carbon 12, oxygen 16. Okay, then what is the next step? Next step, you have to convert this into what? Moles by dividing. Okay, that is, you divided and find out its moles. All moles we have find. And you can see here, in the next step, you have to select the least number of moles. What is the least number of moles here? Here, this one, right? 1.18. Okay, take that. Divide completely with that number. Okay, you will be getting a ratio of that. Okay, then you have to use that as the subscript in the formula. You will be getting the empirical formula. Okay, so Na1, H1, C1, and oxygen 3. Okay, that is what we are getting. Okay, hope you understand this question, how to calculate empirical formula. Yes. Okay, now moving to molecular formula calculation. Okay, if you know empirical formula, how to calculate molecular formula? Let us discuss that. Okay, so in order to find out the molecular formula, what you have to do? Molecular formula. So you have to multiply this empirical formula with a number that is n. Okay, n. And what is that n? N is equal to, you will be given some molar mass of the compound. Okay, molar mass. And you have to divide that molar mass with what? Empirical formula mass. Empirical formula mass. Okay, after finding the empirical formula, you just calculate the empirical formula mass. You will be provided with the molar mass in the question. Or divide it and you will be getting a value of n. Then multiply empirical formula using the value n. You will be getting what? Molecular formula. Okay, let us do the problem. You will understand. Okay, see here. Empirical formula is given as CH. This is the empirical formula given. Okay, so you are asked to find the molecular formula here, and the molar mass of the compound is found to be 78. Okay, first of all, what you have to do? This is the empirical formula, right? Find its mass. Empirical formula mass. Carbon is 12 and hydrogen is 1. You will be getting the empirical formula mass. And next, you have to find the value x, yeah, n. Okay, so how will you find that? You have to divide this molar mass that is given over the empirical formula mass. You will be getting a value of x, yeah, n. Sometimes it will be given as n, sometimes x. Okay, no issues. What is this? This is the ratio of molar mass given in the question divided by empirical formula mass. Okay, yes. And you will be getting a value of x. And what you have to do? You have to divide, you have to multiply CH. This is the empirical formula. Multiply throughout that, you will be getting the molecular formula as C₆H₁₂. Okay, So this is the molecular formula calculation. Very simple, right? Another question. You had to find the simplest formula. What do you mean by simplest formula, guys? Yes, it is the empirical formula. Okay. Here you have to find the empirical formula of a compound containing 50% of the element X. So the X and Y are not given. Which element is not given, but its mass is given. Atomic mass is given, both, and its percentage is given. So convert the percentage into gram, and atomic mass is also given. Find the moles, 50 by 10 and 50 by 20. You will be getting the moles. Divide with the smallest number of moles throughout. Okay. Then what will you get? You will be getting the simplest atomic ratio. Then make it into empirical formula. X2 and Y1, that is X2Y is the empirical formula. Okay. So this is how we are calculating empirical formula. So in conclusion, what you have to do is, first of all, sometimes you will be given as percentage composition, sometimes is mass. Okay. Anyway, you have to divide it with the atomic mass of each element. You will be getting the ratio of moles. Okay. After that, you have to divide the lowest mole amount. Okay. If they are whole numbers, it is empirical formula. If they are not the whole numbers, what you have to do? You have to convert. You have to multiply with the smallest factor to make it whole number. So you will get what? Empirical formula. And what is the next step? Next step is you have to find molecular formula, right? So before that, you have to find a value X, N. How will you find that? Molar mass divided by empirical formula mass. Okay. And you have to multiply that with empirical formula, that small number with empirical formula. You will be getting the molecular formula. Okay. So this is when you see this flow chart, the complete idea you will get how to calculate the empirical and molecular formulas. Okay. Hope you guys are understanding. And is it clear, right? Everything okay, right? Empirical and molecular formula calculation. Okay. Now what you have to do is, you have a question here. You have to try yourself. Okay. The compound contains 4% hydrogen, 24.27% carbon, and 71.65% chlorine. Okay. And its molar mass is also given. You have to find empirical formula and molecular formula. Okay. So this is a homework for you guys. Okay. If you understand the concepts, if you are able to do the problems, now please try this question, and I expect your answers in the chat box or comment box. Okay. Okay, then thank you so much for watching. If you enjoyed the video and find it helpful, don't forget to give a thumbs up and share it with your friends. Okay. Leave a comment below if you have any questions or suggestions, and don't forget to put your answers for this homework in the comment box. Okay. And any doubt you can make sure. Okay, any doubt you can ask, and make sure you subscribe our channel. Click the bell icon. Okay. So stay curious, keep learning, and we will see in the next video. Bye for now. Thank you.